Hello everyone! I'm Yannick and I am going to show you today how embeddings work in OpenAI. And I've built a little small side project this morning utilizing the embeddings model to get and search through a big chunk of text. So, first of all, what are embeddings? Well, they're a factor. Embedding is actually a factor of a floating point number, or a list of floating point numbers, I must say. And using a factor will make it easy to search through a text or use it as a cluster or find recommendations for similar results and a lot more actually. But for my use case, and I believe it's the simplest use case, we are going to build a small search engine searching through a text document that's too large to put into ChatGPT itself. And that text document, let's see if I can show you. If I'm fast enough, I'm sorry if this is slow. This large chunk of text document is too large to put into ChatGPT or for a model to interpret, and I want to search through this document based on every sentence, because I want to know in which sentences they talk about certain stuff. And I will give you that program a little bit later, but first of all, to understand embeddings better, you can visualize it like this. Whenever you embed something, a string of text or a data point, an embedding model from OpenAI, they got a lot of embedding models. They got all these embedding models. Most of the time you just want to use this one. This is the best one and it's not expensive at all. And then what happens is the embedding model changes or converts your text into this factor, text as a factor, to put into a database and store it in some sort of plot if you want to visualize it. And this plot gives you a better understanding of how this factors work inside of a database. Because let's say this factors visualizes a large 2D. This is a large 2D visualization of some sort of database. And when you search through this database, your query essentially gets embedded as well and put inside this database as well. And maybe your query is similar to this point, or similar to this point, or similar to this point. And what happens then, it can find the results that are similar to your query or your data point that you just put in, and then essentially give you back relevant results. Here's another example of how this works. Maybe you got a database, a small database, and these are all points in your 2D graph that shows where that data is stored. So essentially Woof and Meow are very similar results. So it's a very similar result. So they are stored very close to each other. But the query a quarterback throws a football is totally different than these results, or these strings, or these chunks of text. So that's not close at all, but all the way to the left side. So what happens if you search for a query called football? You will essentially be way more similar to this query. So this will be a result that you can get back, and these will not be these will be not similar at all. To give you a small little example, I've built an application that takes in a text that I've showed you earlier, and then eventually lets you query that text and get relevant results back. So first of all, I will give you this test document. This is a test document. It's about a financial report that I want to query through and get some results back. And real quickly, I want to show you how I utilize this. Eventually, when I upload this file, I'm using a Flask library in Python to do this. I split every sentence from this file I just uploaded, and then eventually save it in some sort of data frame from pandas. A data frame in pandas is simply put just some sort of data. How do I explain data frames? Yeah, maybe I can just, yeah. It's a two-dimensional size mutable potential heterogeneous tabular data. It essentially makes it easier to use rows and columns, just like you would use as an Excel sheet. So eventually I use all of those sentences that I've just split it out using this tokenized library, and then create a column called text to put them in. I can eventually even show you how that looks. This is the text column, and this is the text that I've put in for this row. Next, what I want to do is use this text column to create another column called embedding, and here is the magic of OpenAI's embedding. We are using this engine to create a new column, and using this lambda function to convert every row from the text into a vector embedding. So that means every row, the text column in every row, we will get a vector embedding back. Vector embedding is just a numerical, am I saying that right? Are just numbers representing this string, essentially. So, and then I redirect the user to another page, this page. So now the text file has been converted to vectors and stored into this CSV. And then essentially I can search through this database or this CSV file per sentence, because that's the way we split it, and then get back a similarity score because I returned the top 10 list of similar results. So I search for the query billion and get back results containing billion a lot of the times, because those are very similar. The model determined that this one is the best matching result, because it talks about billions, so I guess that's why. Maybe if I search something like economics, I get the best result back. That is, to start, I want to outline the principles that are guiding us through these changing economic times. So the model determined that this is the most similar results to my query economics. And this is just the start of using embeddings, because I've built this small little app, and I'm sorry about this horrible UI, but I've built a small little app in just one morning, playing around with embeddings and seeing what is possible. So now I have a different text file added, and I will search for the phrase messy, because that's what this article talks about. Here we see that messy is the top results all the time, but you can also search for things like football clubs. And what I get back is Barcelona, Arsenal, Barcelona. I don't know why the first result doesn't give me back some club. Maybe it thinks that Blaugranas is a club. I don't know if this is a club. It is. It's called FC Barcelona. I didn't know that. Okay, cool. So yeah, this is just the top of the iceberg. This is nothing special actually, but it's super cool that it's so easy to build such a tool. And one other thing I want to show you is how I perform this search. So when you type in some sort of search like names, you get back a top 10 list of results. How does the search term work? Well, essentially I get this query and I vectorize it using this OpenAI model, using the get embedding, essentially what we did before. Then I use this query to create another column in our data frame called similarities. This column is built on top of the embeddings column, and essentially there's some sort of cosine similarity calculation to get back a to get back a numerical representation of the similar results. Am I explaining that correctly? I'm not sure. Essentially, it just does some sort of calculation using your query that you vectorized to get the most similar results back inside of a different column. And that column looks like this. These results. And then I sort these values in my data frame based on similarities, and then in descending value, and then essentially I give that list back to my front end, which is just some small, simple HTML that looks beautiful, beautifully styled like that. So that's the app, and it's cool that you can build this in just 2-3 hours without ever having to do anything with embeddings and understand what you're doing. So like I said, there's more to this because some people have built some really cool stuff, like this McKay guy who has built a vector database with over 600,000 tokens of all of Paul Graham's essays, articles. He's blogged a lot, and he vectorized all of his blogs so you can search to chunks of his articles. He even put it online. I will play with this later, but essentially he's even put the code he used online so you can search through that. I haven't done that, but I will search through this repository later. But essentially he made a video, you can search. This search will get vectorized, and then you get similar results back. And these similar results are stored in a database. I believe it's a Postgres database using, I believe he talked about this, using Supabase. He stores it in a database using Supabase, which is just a hosting provider for your database. Yeah, it uses Postgres and PG Vector to vectorize the full database, the full chunks of articles, so you can search through them. And how I did it, I vectorize every sentence, but you can also vectorize every chunk of text like this to search through it. And he also added a small ChatGPT integration to answer the questions to make it a little bit more feature rich, I guess. I don't know. But like I said, he converted 600,000 tokens worth for just 0.24 cents, which is pretty insane if I say so myself. So I'm gonna play around with this too a lot more and see what's possible, and hopefully build something bigger than my app, and essentially build on top of that and explore more features and learn more about vector databases, but also learn more about just OpenAI APIs in general and programming and all that stuff, because that interests me a lot lately. So thank you very much for listening. I will put some of these articles I've read in the description so you can search for yourself and see for yourself and learn for yourself, and hopefully you enjoyed this, and I will see you later. Bye.